Hello, I am Professor Urja Mankad from LJ Institute of Computer Applications. Today in this session, we will be discussing some points of fundamentals of computer applications. Today's topics are number system conversion, decimal to any other number system conversion. Main objective of today's session is to know about the number system, what are the importance of number system, applications of number system, and then finally we will look some methods of converting decimal number to any other number system. First of all, we will discuss what is a number system. So, in a number system, each and every numbers are identified by their base. Base is also called as radix. Depending upon the base, the numbers are identified and numbers have their basic symbols. Like if we are discussing about decimal number system, means we all are aware of a number which is a decimal number where we use numbers 0 to 9. These are called as a decimal number basic symbols. So the decimal number has got base 10. Similarly, other number systems are binary where base is 2, where basic symbols are 0 and 1. Octal number system where base is 8, means we are forming numbers using numbers 0 to 7. These are the basic symbols, digits of an octal number. After that, hexadecimal number system where base is 16. Now, when we are saying base is 16, basic symbols are 0 to 9 digits plus A to F letters are used. So, total 16 basic symbols are used to form a number in hexadecimal number system. Now, why we require this number system? So, we all know that computer works on binary number. That is, computer only understands 0 and 1. All the electronic devices work on binary numbers, that is 0 and 1. But being a human, we cannot remember 0 and 1. That is a binary. So, we know the decimal numbers. Now, here we need to convert a decimal number to binary number and vice versa. Apart from that, all the things stored in any electronic device are in a form of bits. That is 0 and 1 combination. 4 bits, 8 bits, 16 bits and so on. So, there we require other number systems as octal and hexadecimal also. Now, where these number systems are used? So, binary number system, it is used mainly where we want to apply some logic like true or false, on and off, where for example in daily life, suppose I want to do some programming for open and close the door, then we can use this binary number. Then in octal numbers are mainly used for representing computer graphics. In Unix operating system, we use octal numbers for file protection system. Hexadecimal numbers are also used where more options are required. So, these are the applications of number system. So, now further we will learn how to convert a decimal number to a binary number. Steps are there. First of all, whenever you are given a decimal number, you have to divide the decimal number by 2. Now, 2 is the base of a binary number. We need to convert a decimal number into binary, so we are dividing it by 2. When we divide a number, we have two portions, quotient and the remainder. So, we have to note down the quotient and remainder separately. Divide the quotient again by 2. And we have to repeat all those division steps till we get a number which is not divisible by 2. And finally, we have to collect all the remainders from bottom to top. That is, the last remainder will be your most significant bit. Now, let's see one example. Suppose I have a number, say 38. I want to convert this 38 into binary. So, first of all, I have to divide it by 2 when we will divide, it will give us a quotient and a remainder. So quotient is 19 and the remainder is 0. We have to repeat the step. Similarly, 19 divided by 2 will get 9 and a remainder as 1. Further, 9 divided by 2 will get 4 and remainder as 1. Again, divided by 2 and we will get 2 as a quotient and 0 as the remainder. Finally, when we will divide 2 by 2, we get 1 as a quotient and 0 as a remainder. Now, we cannot further divide 1 by 2. So, last step, we have to collect our all remainders for the answer. So, consider this last one, then all other remainders from bottom to top. The final answer is 100110. Now, what will happen if we have a fraction portion in a decimal number? So, for a fractional portion, we have to multiply it by 2. Note down the integer portion and fraction portion separately. Multiply the fraction portion with 2 and repeat those steps till you get the result as 1. Now, let's see how it will be done. So, same question, suppose I have a number 38.375. So, how this 0.375 will be converted into binary? So, we will be multiplying the fraction portion by 2 and we will get the answer 0.750. We will consider only the fraction portion, multiply it by 2 and we will get the answer 1.500. Now, we will consider only 0.500. Again, repeat the step and we will get as a result 1.000. Finally, we got our answer. Fraction portion is all 0. So, now we have to collect the whole portion for the answer from top to bottom like this. So, our answer is 0.011 and the final answer for 38.375 is equal to 100,110.011. Okay. Similarly, if I want to convert a decimal number into octal number, same steps are there, only the difference is now for octal number the base is 8. So, we will be dividing a decimal number by 8 instead of 2 because we want to convert a number into octal number. So, let's see the steps. Suppose I have a number 3247. I want to convert this number into octal number. So, I have to divide this number by 8. Same steps are there. We have to collect the quotient and the remainder separately and we will repeat those steps till we get a number which is not divisible by 8 further. Like here, we got 6 as a quotient, 2 as a remainder and now we cannot divide 6 by 8. So, we will be collecting all the remainders from bottom to top and here is our answer 6257. Okay. Similarly, for fraction portion, we have to multiply the fraction part by 8. Okay, we have to multiply it by 8 because it is an octal number. So, we will get the answer 3.000. Now, after point, that is a fraction portion is 000. So, we cannot further multiply it. So, the answer is 0.3. The final answer we can write as 625.3. Similarly, the third number system, that is hexadecimal number system. Now, we want to convert the decimal number into hexadecimal. Here we have to remember that hexadecimal has got base 16, means we are using the digits 0 to 9 as well as the letters A to F. Now, where to apply those letters? For 10, it is represented by A, 11 is equal to B, 12 is equal to C, 13 is equal to D, 14 is equal to E and 15 is equal to F. Okay. So, all the steps are same. Just we have to remain that remainder, if it is 10 or more than 10, we have to write letters A, B, C, D, E, F respectively. Let's see the example. Okay, here are the steps for converting a decimal number 700 into hexadecimal. So, we will divide 700 by 16 as we need to convert it into hexadecimal number. We will be collecting the remainder and quotient, that is 405, and the remainder is 12. Now, when the remainder is 12, we have to write it as a C. Again, further we will be dividing 405 by 16. We will get remainder 2 and the remainder is equal to 11 and we will be writing as B. Okay. So, now the quotient is 2 which we cannot further divide by 16 and we will be collecting all the remainders from bottom to top. So, it is 2BC. So, the final answer is 2BC in hexadecimal. Similarly, if we have a fraction portion that is 0.375, I want to convert it into hexadecimal, I have to multiply it by 16 and we will be writing as 5.900. Again, we have to multiply the fraction portion by 16 and the remainder, or you can say the answer is E.400. Repeat those steps till you get the fraction portion is equal to 000. But here we can see that if we are not able to get any other number than 0.400, then we can stop multiplication and we can collect the result as top to bottom, that is 5E66. Here 6 will be repeated n times. So, we can write up to 4 decimal points, that is 0.5E66. So, the answer of 700.375 is written as 2BC 0.5E66. So, this is the summary. Finally, we have learned the decimal number to any other number system conversion. Method is same. For the resultant number system, we have to divide a decimal number by the output base. That is, for binary we have to divide by 2, for octal we have to divide by 8 and for hexadecimal we have to divide by 16. After all, we have to do some assignment. So, here are some examples that you need to do by yourself. And here are the answers. If you find any difficulties, you can contact me at urja.mankad@lginstitutes.edu.in. Thank you.